Hi, I'm Carl, and in this video we're going to have a look at questions 19 to 21 of section 3 of the Orange booklet. So this is a set of questions about Haworth and Fisher structures. We're given an example here of glucose, which I've copied out, and we're asked in question 19, what is the Fisher structure corresponding to the Haworth structure of fructose, which we're also given. So first of all, I want to have a look at this glucose example to see if there's an easy way of checking if or translating between a Fisher and a Haworth structure. So it's always good, I think, to first of all find a landmark, and we can use the oxygen here for both. If we're moving in this direction through the Fisher structure, it's the same as moving in this anti-clockwise direction on the Haworth structure. We can see, and if I change the color here, that this group is going to be the same as this group. That gives us some more information too whenever we have a look at the fact that there's going to be some hydroxyl groups that are above and some that are below this structure. The ones that are below end up being on the right hand side of this line, and the ones that are above, which are these two, are going to be on the left hand side. So then that gives us a rule that if we know that we're going to be moving around in the same direction each time, that on the left hand side they're going to be above, and on the right hand side they're going to be below the molecule whenever it's oriented like this. Okay, so then that means we can take our structure here, our Haworth structure, and draw out our Fisher structure. Instead of going through the multiple choice, I'll just show you how you could draw it, and then that might make it a little bit easier to work out how you could come up with what it might look like. So let's start off again with our landmark, our oxygen here, and say we're going to move down in this direction. It means we're going to have to move anti-clockwise in this case. So we'll move down and we end up with a carbon. We've got one thing above the molecule, this grip, so we'll write that down here. So HOCH2, and we've got our hydrogen that's hidden from that structure. We'll move on to our next carbon then. It has a hydroxyl group that's below the structure, so we can draw that on the right hand side of our chain here. The next one is above, so we'll draw that on the left hand side. And then we've got on the left hand side another hydroxyl group, and below the structure here we've got another CH2OH group. Then we'll fill in our hydrogens. And there's the Fisher structure for that molecule. So what option does that correspond to? Well, in this case that looks like B to me. So that means the answer for this one is going to be B. If we move on to question 20 now, we've got lots of more diagrams to look at here. It says, of the following, the pair of Haworth and Fisher structures that represents the same molecule is what? So we can use the same method as before, starting at the oxygen and then moving in the same way through both the molecules. I think the easiest way to tell all these apart is that we've got some hydroxyl groups above and below, and if they match up on both sides, or on both diagrams, then we know we've got the right one. So again, remember that if it's on, let me check here, if it's on the left hand side, it's going to be above, so above equals left hand side, and below is going to be the right hand side. So moving around this molecule, we're going to be having a look in this direction, which is going to be this direction on this structure. So we start off with below, above, below, above. So that's going to be right, left, moving up the structure here. As we can see, we start off with left, then right, left. So that's not going to match up with what we were expecting. So we can say that this isn't going to be the answer. Looking at the next one, we have below, above, below, below. So that's going to be right, left, right, right. And instead we've got left, right, left, left. So it's not going to be the right answer for this one either. Again, moving in this direction and this direction, we've got below, below, above, below. So that's going to be right, right, left, right. So right, right, left, right is what we'd expect. So we've got right, left, right, right instead of what we would want, so they don't match up. And what about this final one? If these are correct, then we know we've got the right answer. We've got below, above, below, below. So that's going to be right, left, right, right. So then if we checked our OH grips, we got right, left, right, right. So that is correct, and that leaves us then as D for our answer for number 20. And then 21, we've sort of already answered this. It talks about comparing the two views of a Haworth and Fisher projection. And the last sentence says, for these two views, the groups attached uppermost to the carbon atoms in the ring, which we said were above the ring, in this case on the left. The groups attached uppermost to the carbon atoms in the ring of the Haworth representation are in the same order as the groups attached to the line of carbon atoms in the Fisher representation that are what. So we already said that on the, so we've got our ring here. Anything that's above the ring is going to be on the left hand side. But whenever we were reading through our more complex representations here, we're reading up the page. So you might be tempted to say left side reading up the page, but instead we're told in the first sentence of this question that consider that the Haworth representation in figure 1 is moved in a clockwise direction. And if this is all moved in a clockwise direction, then we're going to be reading from the top down instead of the bottom up. So that means we're going to be reading on the left side, reading down the page. That's where all these groups that are sticking above the ring would be. On the left side, reading down the page, and so that gives us an answer of A. So that's questions 19 to 21. I hope that helped. Thanks for watching.